Hi, this is OrgoChemSimplified, and today we're doing a mechanism problem involving alkenes. Okay, so we have this alkene here, and we're going to react with ICl to get this compound. And the problem wants you to explain why the I and Cl are placed the way they are. Okay, so first we have this compound here, right? And it's going to react with ICl. Okay, so we have this alkene, and that's going to be our source of electrons. And it's going to act as a nucleophile, and it's going to attack the most electrophilic atom. And between I and Cl, I has the most polarizable electron cloud. That's going to make it more electrophilic. So we're going to use this alkene double bond, and we're going to attack the I. And that's going to kick off the Cl. And we're going to get Cl minus from that. So what we get here is I is big, right? So instead of just getting a carbocation, what we're going to get is a 3-ring structure with the positive charge shared. So the positive charge is shared throughout that 3-membered ring. Okay? But most of that positive charge is going to be on this carbon. Now, why is that? Well, this carbon has 3 alkyl chains attached to it, right? It's a tertiary carbon. And we know tertiary carbons are the most stable carbocation. So it's going to have the most carbocation character out of these 3 atoms. So it's going to be essentially, well, it's going to be in equilibrium with this molecule. Okay? So next thing we know is we're going to have a nucleophilic reaction involving a Cl, right? Well, what's the most nucleophilic reagent with Cl? Well, we just eliminated off of Cl minus. So we're going to get that Cl minus back, and it's going to attack the carbon with the most positive character. And like we discussed earlier, it's this carbon. It's this carbon, right? So we're going to attack that, and we're going to take this electron and give it back to that I. So once we do, we're going to get our product. So this I is attached here, and the chlorine is just attached to this carbon. And that's the same as our product, right? So the reason we added this I instead of the Cl is because the I is the better electrophile, right? And the reason we use the Cl to attack here instead of here is because this is a tertiary carbon. Tertiary carbons have more positive characters, and nucleophiles, the Cl minus, is going to want to attack the carbon with the most positive character, in other words, the best electrophile. And if we follow those general rules, that's going to bring us to our product, and this is the correct mechanism. So hopefully that helped, and hopefully that helped you figure out the thought process behind organic chemistry, right? So the key to organic chemistry is not to memorize reactions, is to figure out characters of certain compounds, and what kind of intermediates are more stable than others, and try to follow the logical path to get to your product. So that's kind of the way you want to think about an organic chemistry problem. So hopefully that helped. If it did, like the video. If you have a question, feel free to leave a comment. I'll try to get back to you. And watch some of our other videos as you go through organic chemistry. Hopefully it'll help. But thanks for watching.